PreCalc, PreCalc, PreCalc. This is Monday's class, or Monday night class after Monday's day class on the 23rd. And we are looking at another conic section. I'm not going to cover too much because I'm not sure how much of the circle work we were able to finish today. So we'll go ahead and title this definition after you write it. So write it, pause if you need to. The set of all points xy in a plane equidistant from a fixed line, which we call the directrix, and a fixed point, which we call a focus. And that fixed point cannot be on the fixed line. No, no, no. All right, so we will try to imagine what this is by examining what it's saying, and then we'll put in the answer right here. All right, so say we're on a coordinate plane, of course, and we have a fixed line. I'll pick this line, any old horizontal line, and a fixed point. All right, so I want the set of all points. So this is my focus. This is my directrix. So what I'm looking for is a set of points that is the same distance from the point and the line. So what do I mean by the equidistant? Say if I look from here to here, what point is equidistant? The same distance from the point as it is from the line. Well, if I'm looking at these, it would be the point right in between. So I'll put little x's for that. What if I go out over here? Well, I'm looking for another point that is the same distance from the point as it is from the line. So say I go over this amount and down this amount. They look about the same. So this point is the same distance from this point as it is from the line. And if I go out over here, maybe about right there, this distance from the point to the line are the same. So I'm looking for all the points. There's an infinite number that are the same distance from this point as they are from to the line. So over here on this side, I'll get one about right there. So the distance from here to here are the same. And maybe about right there. From here to here are the same. And maybe I go way out here. Is the distance from here to here about the same? Looks like it. And similarly over here. So if I find all of those points that are the same distance from the point as they are to the line. So that's saying every single point has that characteristic. So let's look at this one. We're saying that the distance between every point, even that one, from here to the focus is the same as it is from here to the line. And I'll remind you from geometry, distances from a point to a line are always measured perpendicularly. All right, so perhaps you can see the figure that we're studying today. It is also, remember, it's called one of our conic sections. It is also visible when you have a cone balanced on, inverted cone balanced on, I guess a cone balanced on an inverted cone, like that. If we take a sharp piece of paper or plane and we cut it straight through here, so imagine a sharp plane intersecting with the cone at sort of this kind of an angle here. Can you look down and visualize the intersection between this plane and the cone? It's going to look something like that. It's hard to visualize and draw, but the intersection between a slanted plane like that cutting into our cone at this angle will also give us this shape. And it is our old friend, the parabola. I'm assuming you have studied parabola in your deep, bright math past. So, the thing is, this time, we are not going to study it in the same way. So this is really not a missing thing. We're going to, this is again called a locus definition. And you were not presented to it. This was not presented to you in this way. You had parabolas from a different viewpoint, was just as correct. But this is how we're doing it this year. So you'll see all the perspectives. So we're looking at the set or the location of all points. So I could have said the locus of all points, which means the location. That indicates that you have a locus definition. Either way, it's still a locus definition. So let's go ahead and give you some terms about the parabola. So if you have the parabola, let's draw a similar one. Here's the directrix. Here's the focus again. When you put in the parabola, remember it doesn't touch either the focus or the directrix. So that's kind of interesting. It doesn't really touch either. Notice the focus is enveloped by the parabola. The parabola is like protecting it. It's not touching it, but it's wrapping around it. And the directrix is outside of the parabola. It does not touch it either. So this, I don't have a very good picture here because this focus and this point on the parabola is supposed to be equidistant from the two. Let's see if I can coax this eraser to work. Doesn't have much left in it. So let's get our perspective better. The focus to any point on the parabola is equidistant between the focus and the directrix. So that looks like it's in the middle, so I'll make my directrix right there. Alright, so now I have a better perspective. Let's go ahead and look at the terms that I want to show you. Alright, this point here is called the vertex. It's the lowest point in this parabola. If the parabola was inverted, it would be the highest point. If it was opening to the right, it would be the leftmost point. If it was opening to the right, it would be the leftmost point. So, the most extreme point in the parabola is called the vertex. There is a line that cuts the parabola exactly in half, and that would be called the axis of symmetry. And also, there is another important point and definition, and that is the distance from the focus to the vertex is very important, and that's called P. We thought long and hard and we called it P, perhaps because of the parabola. Alright, with those definitions, let me give you standard form for the parabola. Standard form is x minus h, there's Hector, equals 4p times y minus k, there's Kyle. That's one way to have standard form. When x is in the squared term, notice y is not. Y is a linear term. When x is in the squared term, that means it's a parabola that is horizontal. So a horizontal parabola will open left and right, like that. All right. If P is positive, it'll open to the right. So this will be a positive P. And if P is negative, it'll open to the left. All right, the other standard form, y minus k quantity squared equals 4p x minus h. Very similar in form, except now the y term is squared and the x term is not. So this is what we see with a vertical parabola, which has its opening up and down. It could be this, or it could be that, something like that. So when P is positive, it opens upwards. So this has a positive P, and when P is negative, it opens downward. All right, so let's say that we have a parabola and its vertex is known to be 2, 1, and the focus is known to be 2, 4. Can you put that into standard form? Well, let's decide whether we have a horizontal or a vertical, and we'll do that with a quick sketch. So we're going to go over 2 and up 1. There's the vertex. And then we're going to go over 2 and up 4 to find the focus. So if this is the vertex and this is the focus, the parabola has the most extreme point on the vertex, and the parabola also envelops or protects the focus. So we must have a parabola that is vertical opening upward, because that's the only way I can draw that. So it goes through my vertex and it envelops, protects, guards, shields the focus. All right, so that means we're going to have this form. It's a vertical one, opening up and down. So I'll go ahead and write that. Y minus k quantity squared equals 4p x minus h. All right, we'll recall that the vertex is Hector, comma, Kyle, just like with the circle. And so I'm going to plug in h is 2 and k is 1. Y will stay y, and it will remain a variable. K will take on a 1, and x will remain a variable, and h will take on 2. And so far so good, and we'll be done when we finish find P and simplify. Recall what P is. It's the distance between the focus and the vertex. So I'm going to look at my sketch. What is the distance here? Well, if I was at, I went over 2 and up 1 to get here. I went over 2 and up 4 to get here. So the distance between this is in the y direction, and it's the distance between 1 and 4, which is a 3. So I can go here where my P is and put a 3. It's held by multiplication to the 4 that's in the formula. So I get y minus 1 quantity squared equals 12 times x minus 2. All right, that is standard form, and it's all done right there. All right, that is an introduction that will get you started on the parabola problems. So good luck with those, and see you later. Bye for now.